So, good morning, everyone. This is Alex, and there will be a series of videos for problem set 2 because this one is really a hard one, and I think you have to apply the concepts really well, and you have to understand clearly what the indifferent curves, like the MRS and the optimal choice mean to finish the problem set. So that's why I record several videos. I will record basically maybe 2 videos on question number 5 and maybe 2 videos on question 1 and 2, and also like one video on question 3. For the 2 videos on question 5, the first one will be like a review and also summary of the points, of the knowledge points you have to use in the to tackle the question number 5. And the second one will be like the answers to the question number 5. So if you feel confident and you think you do understand clearly what the indifferent curve means and how it develops, you can just close this video and skip to the next video. But I strongly suggest you go through the PowerPoints I made, which may give you a better idea on how to use the indifferent curves and how to understand the indifferent curves. So so this video is section 1, and it will go through the main points as follows. First one will be the concepts and the graphic features of indifferent curves. And second one, the definition and the derivation of marginal rate of substitution, the MRS. Third one will be the different shape of indifferent curves. And the fourth one will be the optimal choice, especially in the very like a weird shape of indifferent curve. So first one, let's go to the first point. It's the concepts and features of indifferent curves. For the concept, I think you all know this well. All the bundles on one indifferent curve provide the same utility level to the subject, which means for different subjects, for different people, indifferent curves can vary. And that means when we are thinking about indifferent curves, we are thinking about the indifferent curves for Alex or for Sam or for someone. It's not indifferent curves for the class as a whole. We can build an indifferent curve for the class as a whole, but that's quite different from the indifferent curves with each individuals. Okay, so the graphic features which I want to clarify. I think from the textbook you'll know some features about the indifferent curves, and here I just want to say when we are looking at an indifferent curve or a series of indifferent curves, there are 3 features we want to focus on. The first will be the slopes, and I use slopes instead of slope. I put an S here because even on one indifferent curve there are many slopes, and because you can go to note 1. The slope of a point on a curve, because we are discussing a curve, the slope of a point on a curve is the slope of the line tangent to the curve at that point. I think you'll know this, and can be calculated using the first derivative, which means a curve, each point has a different slope, so I call it slopes. And also a straight line, if you go to note 2, a straight line is just a curve with the same slopes on all points. So actually the straight line is like an outlier, but we use this outlier pretty often, especially in the simple the situations. We assume, we made assumptions that the curves are straight lines. So so first the slopes. And when you think about the slopes, I want to clarify that the slopes are determined by preference. It is not determined by the MRS, because both the slopes and the MRS are created by economists. So they are all theoretical ideas or concepts. And what really behind the idea of slopes, what really determines it is the preference. Only the preference determines everything. So that's why maybe indifferent curves is like the reflection or something. It's determined by the preference. Okay, and for the MRS, when you know the MRS, you can know the slope, because from numerically, the the amount, like the number of MRS is exact to the negative to the slope, right? So the MRS is a negative to the slope. So I hope you can understand this, because the slope is not determined by MRS, it reflects the MRS. Once you know the MRS, you know the slope, but that does not mean MRS determines the slope. The preference itself determines the slope. And for slope here, it's usually like the positive or negative, so it's going upward or downward. And if you want, we will go. Then we will go to like the each point of the slope of each point in the curvature part. So first is slope, and the second one is the levels. The levels means which indifferent curve has higher utility levels, and this is also determined by the preference. And the third one is curvatures. It's a curvature, which means the curve maybe shift bold outward from the origin or bold toward the origin. So that's something we want to discuss. So if we know a slope, it maybe it's upward, and maybe it's downward sloping, and then we know the levels, means the further line from the origin has higher utility, and we know the curvature, maybe it's concave. Then we can draw like the indifferent curves. Yeah, I will clarify this further. So if we use 3 arrows as determine, what is wrong is MRS determines slope and determines preference. That's a wrong logic, right? And what is also wrong is preference determines MRS and determines slope. This is wrong because preference determines MRS, and MRS equals to the negative slope. The relationship between MRS and slope is they are the same thing. You can think about they are the same thing. We usually say that the MRS is the negative of the MRS is the slope, or the negative of the slope is MRS. Okay, so this is also consistent with the steps of answering questions. When we got a question, we usually got a utility function first. So the utility function is given, which means we got a preference. And we use the preference, we use some derivative method to calculate the marginal rate of substitution. We use a utility function, we use a preference to get the MRS. And once we get the MRS, we get the slope. So preference is there, but MRS and slopes are all invented. These two ideas are all invented by like the economists. Okay, and I will give you an example on how preference can determine the indifferent curve. For example, the slope. How preference can determine the slope? If someone likes both x and y, like both two goods, then the slopes are always negative, which means that it will be a downward sloping line. I think you can get information about this from your textbook. Okay, you can see proofs there. So that's how the preference determines the slopes. And the levels. If one likes both x and y, if one prefers to have both, then the curve further away from the origin has higher utility compared to the curve which is closer to the origin. And for the curvatures, so this is a little bit tricky, but I hope you to maybe think of this step by step. So first we want to start with the preferences. So if one prefers to keep the last unit of y, which also means if one prefers, or if one is reluctant to give up the last unit of y, then the slope is approaching 0 to the right end. I mean the slope of the points is approaching 0 to the right end, because you don't want the line to directly hit the x-axis. I will draw it here. So it's like this. If a line looks like this, it hits the x-axis, then that means you will directly give up the last unit of y, right? Because you go from here to here, you just give up the last unit of y. But if the line looks like this, I'll use another color. and it takes a long time for the line to hit the x-axis, which means before you give up the last unit of y, you are requiring a lot of x's for compensation, which means you don't want to give up the last unit of y. And this concept will also help us answering the question. So please remember, if you prefer to keep the last unit of y, the slope is approaching to 0 to the end. And the same, if one prefers to keep the last unit of x, then the slope of the indifferent curve is approaching infinity, infinity to the left end, which means the curve goes very steep to the left end, like this. You see, it looks like this. Oh, sorry. Now erase this. Maybe this line. Yeah, this is better. So it's going. The slope will approach infinity, and the line is going steeper and steeper to the left end. So that also from that we can say diminishing marginal utility is the same to want to keep the last unit, right? Diminishing marginal utility means you always want to keep the last unit. Means the more you get, the less utility you can derive. Okay, so that's like the 3 graphic features when you want to think about an indifferent curve. And the second point, for the second big point, will be the definition and the derivation of MRS. I stated this wrong yesterday, so I have to correct myself. The MRS xy, if the MRS x, y equals 2, means one will give up 2 units of y for an additional unit of x. So here you see is 2 unit. You will give up y and for 1 unit of x. So y comes first, and which also equals to the this MRS equals to the negative of the slope at that point on the indifferent curve. So yeah, again, MRS xy equals to 2 means one will give up 2 units of y for an additional unit of x. And the derivation, you can see this on the textbook, page 91. And you can get the formula here. By dy, I mean the delta, like the triangle sign, the delta y, the change in y. And dx, I mean the change in x. And I make 2 notes here. The first one is MRS is positive. It's positive when the consumer likes both goods. When the consumer likes both goods, if you still remember, that means the slope, like it will be down. The indifferent curve will be a downward sloping line. The slopes, all the slopes of the points on the indifferent curve will be negative. And when that happens, because MRS is a negative to the slope, and when the slopes are negative, then the MRS are always positive. Okay, but it can be negative. I want to see MRS can be negative if the slope is positive. If the line is upward sloping, is positive sloping, then MRS can be negative. And second, you can see the second note here. Since from the derivation we also know the MRS can be written as dy over dx, the negative dy over dx, and x, the x part is on the numerator. Numerator is on the numerator. So the interpretation of the MRS should be give up how much y for 1 unit of x, because x is on the numerator. So it's just 1 unit of x. You just divide y by x, right? Okay. And the third part will be the different shapes of different curves. So the first one will be a negative or downward sloping, and with downward sloping indifferent curve with diminishing marginal utility, and it's really ordinary. It's really common. I thought maybe it would be better if we have some practice on this one first, but actually professor directly gives you like a more complicated scenario. So yeah, so this is not enough. You have to also recognize the other graphs. For the second graph, you'll see the indifferent curves IC1, IC2, and IC3 are upward sloping, which means they have positive slopes on each point. I mean the slopes on each point on the indifferent curve is positive, and that's special. And that happens when you hate one good and you love the other good. For example, if you really dislike apple and you love banana, and you put apple on the x-axis, banana on the y-axis, and when you get more banana, you want more apple to when you have more apple, you want more banana for compensation. So which means one apple, one banana, and three apple, three banana has the same utility for you. So that will make the indifferent curve upward sloping. That's very special. And also, you can see the arrow on the graph. The arrow indicates like the preference direction. The preference direction, which means you see the rightward arrow means you prefer X. You prefer X, right? The more X, the more X you have, the better you are. And when the downward arrow, the downward arrow indicates you don't like Y. Means the less Y you have, the better you are. So these two arrows are usually used to indicate the levels. Like the levels, yeah. If you still remember like this page, like here, the levels determined by the preference, and the preference direction is usually used to mark like the which level is greater. And right, let me try to draw a graph on this. For example, if you have a like the preference direction of this side and this side, so which means you prefer more Y and you prefer more X, and then U1 is going to be greater than U0. Okay, and if you have a preference direction like this, which means you prefer more Y and you prefer less X, then indifferent curves will be like U1, U0, U1 is greater than U0, because you see this is a direction. To this, this direction indicates the higher utility levels. Oh, sorry. And if the preference direction looks like this, no, that's the same. Okay, so which means you prefer more X and you prefer less Y. And then the indifferent curve may look like this, but U1 here, U1 is greater than 0. So the preference goes this way. Yeah, so that's a really useful tool to indicate like the preferences. And that happens when you have positive slopes, when you dislike one good and you like the other good. And here I'd like to discuss like the concave and the convex indifferent curves. It's about the curvature. The third feature of the graph. So even a downward sloping line can have different curvatures. So this is downward sloping, and this is also downward sloping. So 1 and 2, they are both downward sloping lines, but we call this one, we call it a concave, and this one we call it convex. And for concave and convex, concave curves bolt outward away from the origin. So you can see this is also a concave curve, but it's it's a special one because it's like it has a 90-degree, it's like the angle, right? So it's actually not a curve. It's just two straight lines. It's also a special form of the curve, and this is also concave. And for convex curves bolt towards the origin. And what I want to clarify here is the concept of concave and convex are relative. You can see if this is concave, this is convex. What if we just rotator graph, and then the convex line can be concave, and the concave line can be convex. That means we have to set a reference before we talk about concave and convex. And here on the graph, indifferent curve graph, we usually use the x-axis. We use the x-axis as a reference, which means the number one, this line, the red line here, the blue and red line here is concave compared to the x-axis, and the black line here is convex compared to the x-axis. Okay. But usually when we talk about concave lines, we know we set the x-axis as a reference. That's like the accepted by all the Schulers in all the economists. So this is concave curvature. And also we have perfect substitutes and complementary goods. And I think you discussed some in your class, and you can also find find some reference on your textbook. I forget the page, but it should be in the indifferent curve section. And I just made a summary table which may help you with the understanding. So for each of the four scenarios, the first one is ordinary. We have a very ordinary traditional or convex indifferent curve, and the second one is concave curvature, and third one will be perfect substitute, and fourth one will be the complementary. For the ordinary indifferent curve, the slope is down. The slopes is negative, and which means the MRS is diminishing. So actually, let's go to this. For this curve, first we want to discuss the slope. Is this downward sloping or upward sloping? It is downward sloping, right? So it is downward sloping. And sorry, I think I have to fix this. I have to fix this later, because I should put negative or positive in the slope cells and put the diminishing and the increasing in the curvature cells, and that's more relevant. I will change this. So the slopes for the ordinary, I can do this right now. I think how to stop, how to quit. Yeah. So like here. This is negative. It's downward sloping and means the slopes are negative. And concave is still negative. And perfect substitute usually is negative. And complementary also negative. So it's all downward sloping. But for the curvature, here is convex, means we have diminishing marginal utilities, and concave means we have increasing marginal utility. Straight line means we have a constant marginal utility, and L-tab means we have two extreme of marginal utility. Yeah, that should be the right form. Present. And for the levels, you decide that by the preference directions. Okay, so these are all series, and we will use this in answering the questions. Optimal choice. The concept of optimal choice is maximize the satisfaction level while within the budget constraint. I think that's something you know from the textbook. But we use a lemma here. It's like something we infer from when we discuss like a strange indifferent curve, especially the concave indifferent curves. When one has concave indifferent curves increasing marginal utility, the optimal choice happens on the corners, and we don't know which corner. In this graph, we see it's a left top corner, but it may be the right bottom corner. It can be the right bottom corner if the indifferent curve maybe looks differently. So We only know the optimal choice happens to the corners, but if you want to solve the optimal choice, then you need more information, and that's why maybe in question number 5, in the last one, we cannot clearly state it. We cannot decide maybe will the what's the name? Will he end up with all the Pokemon or the baseball? But we can know that he will only have one card finally. So you can see the graph here. The utility level at point B is greater than utility level at point Z, which is the same to the point L, and is greater than H, and is same to K, and is greater than the O. So point B has the highest utility, and that will be the optimal choice when we have concave indifferent curves. Okay, so that's all that's the first part. That's all the points. All the I want to reiterate and I want to clarify before we really go into the question. And I hope this PowerPoint can help you summarize summarize and understand the indifferent curves. Always remember the three graphic features of indifferent curves. If you want to draw indifferent curve, first you want to think, will that be upward sloping or downward sloping? And the next question will be, what's the preference directions? Which indifferent curve has higher utilities? And the third question will be, will it be concave or convex? Will it be both towards the origin or away from the origin? Once you answer these 3 questions, you can draw the indifferent curves. Yeah.